Hello everyone, my name is Susan. I'm from SVC College, Bangalore. My question is on V22 CS 160. Introduction to Probability. Probability is the study of likelihood and event occurring. It is fundamental concept in mathematics, statistics, and everyday decision making. Basic concepts of definitions. In the context of probability, basic concepts and definitions lay the fundamental for understanding the principles and calculations in the field. Key terms such as events, outcomes, and simple spaces are essential for interpreting probabilities. Understanding the difference between independent and dependent event is also crucial in probability analysis. These concepts set the stage for deeper exploration of probability rules and axioms. Probability rules and axioms. There are three conditions: sample space, probability axiom, additional rule. The set of all possible outcomes of a random experiment. The probability of an event is between 0 to 1, and the sum of probabilities of all possible outcomes is 1. Additional rule. The probabilities of the union of two events is sum of their individual probabilities minus the probability of their interactions. Condition probability. Define condition probability. Conditional probability measures the likelihood of all events occurring given that another event has already occurred. Calculating conditional probabilities. It involves the intersection of two events and can be calculated using formulas. Real-life application. Conditional probabilities in various fields such as healthcare, finance, risk cases, and make information combinatorics and counting principles. Permutation, combinations, binomial coefficients. Permutations are arrangement of objects in order. For example, arranging a letter A and B in all possible orders. The formula is given by NPR is equal to n factorial by n minus r factorial. Combinations. Combinations are selections of objects without considering the order. For example, choosing a group of students from a committee. Formula NCR is equal to n factorial divided by r factorial n minus r factorial. Binomial coefficient. Binomial coefficient represents the number of ways to choose from set of distinct elements. Formula n choose r RCR. Probability distributions. Probability distributions represent the possible outcomes of a random variable and their likelihood. Each distribution has unique characteristics such as mean variance and shape, which influence statistical analytics. Common distribution includes the normal, binomial, and Poisson distribution. Each application to different real world such as financial equality control and demographic. We can see the graph here. The theorem is here in 0.5. Answer z is greater than 0, 0.5. Probability distribution. Expected value of variance. Expected value. The expected value is also known as the mean representation, the average outcome of a random variable. It is a crucial concept in understanding the central tendency of probability distribution. Variance measures the dispersion of spread of the values in probability distribution. It qualifies how much the values deviates the expected value. Understanding variance essential for risk. Law of large numbers. Large sample. The law states that as the sample increases, the sample mean approaches the population mean. Probability distribution. It demonstrates that the sample average will converge to the expected value as the number of trial increases. risk analysis. It is essential in risk assessment where large sample provides more accurate representation of true risk. Central limit theorem. Sample mean approaches a normal distribution of sample mean become more normal as sample size increase. Law of large numbers contributes to a central limit theorem. Application of probability. Insurance using probability is calculated risk premium and financial application in stock market analysis, risk management, gaming. Probability theorem applied design gaming